Thank you very much. It's an honor to be presenting at this conference. This is joint work with Fabian Kosse from LMU Munich and Enrico Miglino, a PhD student at UCL. But also there's a whole team behind this study that would have been impossible without them, our project consultants and the Ministry of Education in Chile. So I'm going to start with some statistics that are not going to shock you. So this is for the United States that are better off. For example, with parents who are more highly educated are more likely to have higher education degrees. So for example, if you, here we show this gradient by parental education. Now let's look at the difference between this green bar and the blue bar, and let's think that is a measure of inequality in participation in higher education. Let's see how that is across the world. Well, these are OECD, some OECD countries. You can see there's substantial inequality according to this measure everywhere, even in countries that we think of as very equal, like Sweden and Finland. Now, these statistics have not gone unnoticed by policymakers and researchers. So there's a large focus on whether there are constraints that disadvantaged students have in participating in higher education, and what policies could mitigate these constraints. Now, what instead has received a lot less attention is, do these policies have any incentive effects on the behaviors of students before college? Now, why is that important? Well, that is important because if they do have incentive effects, they might affect how effective these policies are at bringing disadvantaged students into higher education, which is the goal of these policies. And surprisingly, we know very little about this interaction. So we're going to focus on preferential college admissions and their incentives on pre-college effort. So preferential college admissions, they lift something that you could think of as a human capital kind of constraint. So think of disadvantaged students. They are students who, from the moment they're born, they go to lower quality schools, they receive lower quality educational investments. So by the time they're 18, their preparation might not be enough for them to be able to pass university entry exams. And so the explicit goal of preferential admissions is to facilitate their admission to college. So it's almost tautological to say that preferential admissions have a direct positive effect on the admission chances of the students that they target. Now, what we're going to show in this paper is that when students are misinformed about their admission chances, preferential admissions can actually have an indirect negative effect on the admissions and the enrollments of the students they target. Now, I have highlighted two words, indirect. That is because the effect is gonna go through the incentives. Misinformed, I highlighted it because if you think about it, these policies, they target disadvantaged students who tend to come from families with no first-hand experience of the college admission process. So these are precisely the students who are most likely to be misinformed. So this could be a widespread phenomenon. Now, the bottom line is that preferential admissions can stifle the upward mobility of some disadvantaged students. And this sounds quite bleak, but we'll see that as we understand where this effect comes from, we'll see that it very much hinges on misinformation. So this is something that is potentially fixable with informational interventions. So in order to answer our research questions, we need a few ingredients. First, exogenous variation in admission rules. So that is, if you're interested in identifying the causal effect of preferential admissions on student enrollment, but also on pre-college behaviors, well, it would help to have exogenous variation because with observational data, it's difficult to tease out the causality. For example, regions of a country or universities that adopt certain preferential admission rules may do so based on characteristics of the student body that are unobserved to us, and that would bias our estimates. So what we do, we're going to exploit the randomization of a real-world preferential admission policy. Second, you need longitudinal data on pre-college behaviors like effort, achievement, and then beliefs, admissions, and enrollments. So the data has to be longitudinal so that you look at the pre-college effects and link them to later outcomes, but you also need data on beliefs. And even in a country like Chile, which is going to be the lab for today's talk, that has amazing admin data where you can build this individual level, longitudinal data set where you follow the path of individual over time, even their beliefs are typically not available. So our approach has been to go in the field and conduct our own data collection, and then we combine our primary data with admin data, and we build a 6-year-long panel data set around the time of the college transition. And then finally, we're very much interested in understanding what is the role of these incentive effects. In other words, that means, well, what would the effectiveness, how effective would this policy be if there was no incentive response, or if there was a different incentive response? For example, if students have correct rather than biased beliefs. Now, you can see that these are counterfactual scenarios that we do not see in the data. So this is something that naturally calls for simulations from a model. So what we're gonna do, we're gonna develop a dynamic model that incorporates these belief biases, and then we'll conduct some counterfactual simulations. There's a very large literature out there on preferential admissions. This literature has mostly ignored incentive effects on pre-college behaviors. There is a smaller, more recent literature that looks exactly at that. The first stream of the literature is empirical literature that tries to establish the existence of effects on pre-college effort and achievement. And this literature is very careful in trying to tease out causal effects from observational data. So we contribute to that part of the literature by providing the first experimental evidence. And then, as far as I'm aware, there's only one study out there that tries to understand the role of these incentive effects. And as we said earlier, that necessarily calls for a model and for a dynamic model. Now, this is the first paper, and so it starts from the first natural assumption, which is to assume rational expectations. We're gonna relax that assumption. We'll be able to do it thanks to the data that we've collected, and we'll actually show that it's important to relax it, because the type of perverse incentives that we find, you would fail to detect them if you impose rational expectations on the data. So let me give you some context. The policy we're going to study is called PASE. It was introduced in Chile in 2014. It's programmed for the effective access to higher education, the translation. So this is a policy that targets schools that have students who are disadvantaged. So this is a picture we took during one of our focus groups in one of the targeted schools. Let me show you how these students look like. These are the students in the targeted schools compared to the average Chilean. Let me just point out two stats. The average income is half that of the average Chilean, and the baseline test scores are 60% of a standard deviation below the average Chilean. So these are undoubtedly the most disadvantaged students. So the explicit goal of this policy, like any preferential admission, is to facilitate the admission and eventually the enrollment in college of the students in the targeted schools. Without PASE, 8.5% is the enrollment rate. So PASE plan. So percent plans are emerging as popular alternatives to affirmative action. For example, in the United States, California, Florida, Texas have their own percent plans. So PASE guarantees college admission for students whose grades put them in the top 15% of their school. So what is the idea behind a percent plan like PASE? The idea is these students are disadvantaged, so let's have them compete with equally disadvantaged students for college admissions, rather than compete with the entire population where the more advantaged students are, and it might be more difficult for them. Now, PASE enters a school at the beginning of the 11th grade. So that means at the beginning of the 11th grade, the students know that there is this top 15% admission rule. So that means that they have 2 years' time to adjust if they wish to. So college enrollment in Chile, this is important information to understand what the policy is doing. If you are in a normal high school that doesn't have the preferential passive channel, you have the regular channel available to you. So that's a centralized admission system. Its admissions are mostly based on the score on the entrance exam. It's called PSU. So the higher your score, the more likely you are to obtain an admission. If you are a student in a school that has the passive policy, then the regular channel is always available to you. On top of that, you have the passive percent plan channel. So if you're in the top 15% of your school, you get a college admission. Now, admission to what? Well, this policy covers the same majors that are available through the regular channel, and the quality of the college major pairs, so of the degree programs, is the same. It's very comparable. Importantly,
can I just ask you one clarification? Is 15% corresponds to the top 15% on GPA or in the same admission exam?
That's a really good question. So this is on the GPA. And in fact, and I click on, I have an appendix link, we'll talk about it later. So this is on the GPA. The entrance exam is a standardized test. So it's a different
I just ask because basically, if I understand the system well, the teacher has a lot of influence on the grades of the students. So changes on grades not necessarily reflect student responses, but they could also reflect in some way teachers' reactions, right?
That's true. And that's why we went through the hassle of surveying also the teachers and the principals in these schools. And that's why we very carefully look at how grading changed. And it's something we can do thanks to the data we have, because we have simultaneous standardized test scores as well as grades. And it turns out whatever I show you today is not driven by grades. So it's true, grades carry different value, but I can talk about it a little bit later, more later, but it's something we can rule out in our case. PASSE do not crowd out regular seats. So what that means is that capacity constraints didn't kick in. These seats are supernumerary, and that is because it's still a small program. Just 1% of enrollments are through this program. So that means that PASSE didn't make it mechanically harder to get in through the regular admission channel, which is something that could happen with a bigger program. So in 2016, this policy was randomized, and the randomization is a school level RCT. So out of 128 schools that the government identified as eligible based on the vulnerability of the students in those schools, the low SES of the students, 64 were randomly assigned to be treated to have PASSE. 64 were randomly assigned to control. And at the time, I was working as an external advisor to the government together with the project consultant. And so I was involved in this decision. We observed no strategic selection of students, more advantaged students trying to go into disadvantaged schools. It didn't occur in our case. The reason is that the announcement was made after the deadline. The announcement that a school was in PASSE was made after the deadline for school enrollment. A student needs to be in PASSE in the same school for the last 2 high school years. So there was no incentive to change school later on either. We do further checks.
One question though, does the school, could it be that the school itself responds? So if a school knows that it's part of this program, could it be that it somehow behaves differently? That the teachers behave differently in grading, or they put more effort, or that they somehow do things differently?
Yes, so I will talk about it. We measured a lot of things. Nothing happened at the school level in terms of resources, support classes. We measured student effort, focus of instruction, grading, allocation of teachers to schools, a bunch of factors, and it's not driving the results. So let me first show you what the results are, because then it will become also clear why this is not coming from teachers. So in principle, it's something could happen. That's why we surveyed everyone. So the covariates are balanced. That's another symptom of lack of strategic selection. So what we think is an advantage and a nice feature of this study is that we have the randomization of a real world policy. So that means that the choices the students make, they have impacts on high stake outcomes, like whether they go to college or not, and they can have potentially long-term consequences for them. So this is a government-backed policy. And so this is not something that you can easily recreate with a smaller scale field experiment. So in terms of data, we start by building the best data set that we think administrative data set that we can build. So we gather information spanning from the grade 9 up until 2 years after leaving high school. We have baseline test scores, we see GPA through the years, demographic characteristics, and then we have college information, entrance exam scores, applications, admissions, enrollments through the regular channel and through the passage channel. So what is missing? However, we don't have information on beliefs and on effort. And also there's no end of high school standardized test score. We do have GPA, but GPA is not comparable across schools. And we do have entrance exam scores, but that's a selected sample who takes a test score, and that could itself be affected by the treatment. So that wasn't good enough for us. So we went into the field to collect the missing variables. We went at the end of 12th grade. We collected data on 128 experimental schools. All of them participated thanks to the Ministry of Education encouraging them to participate in our study. So the key variables, there's an achievement test, that's a 20-minute math test that all students took. By doing so, we actually solved this issue of the lack of standardized test scores at the end of high school. It's actually prevalent in the United States too, for example. It's not available. And then we elicited beliefs and effort. And I'll talk more about that. Our response rate compares favorably to the response rate of the Ministry of Education surveys themselves. In the regression analysis, we will use inverse probability weights, while in the estimation of the structural model, we allow for survey non-response, so survey attrition based on unobservables. So we allow for the individuals who are in our survey to be different in unobserved ways from those who are not. And we can do that because we have admin data for everybody. Now, our data set is linkable to administrative data through a unique student identifier. So I'll just flash this. This is just the overall data set. You see how we merge together various data sets. The sources are a mix of administrative and primary, and we follow students from grade 9 up until 2 years after they leave high school. So let me now describe the sample to you. So these are descriptive statistics of students in the control group because I want to show you what the path to college is, typical path to college of these disadvantaged students. So 65.5% of them sit the college entrance exam, but their scores on the entrance exams are 60% of a standard deviation below the average among all test takers in the country. So they get very low entrance exam scores. So it's no surprise that upon observing their PSU entrance exam score, only 21% apply. And it is those who apply are those who have the highest PSU scores among those who took the exam. So you can already see how this admin data is already signaling to some overconfidence. These students sit the exam, potentially they expect it's a good idea, but very few of them actually get, apply and later on get admitted. We'll see when we look at our belief data, that our belief data confirms this. So they actually, the admin data and the survey data fit in nicely together. So 11% are admitted, 8.5% are enrolled, 6.5% are still enrolled in the second year. Now, these statistics, I think, is interesting. This is telling us that among all those who are admitted to college, half of them come from the bottom 85 school. Two things. One, there is heterogeneity in a school, in student quality across schools. So in certain schools, it's easier to get a regular admission rather than to be in the top 15% of your school. These are the high performing schools. And then the second thing that these statistics tell us is that in a sense, for these students, it's as if the policy is not doing much to them. They were already getting admitted and they graduate in the bottom. They are in a high performance school where it's difficult to be in the top of their school. So to the extent that these students change their behavior, before college, there is a sense that this can only harm them in terms of their admission chances. So what do their subjective beliefs look like? Well, we saw that their entrance exam score was 60% below the average, but they think they are like the average in the country. And in fact, if we compute a measure of their bias, so this is for each student, we see what their believed entrance exam score, and then we take the difference with their actual exam score. The difference is 60% of a standard deviation. So that's large overconfidence. And in fact, they also expect that they're going to be admitted through the regular channel, even though only 11% of them are admitted. So now let's look at the bottom 3 rows. So these are statistics about their beliefs about the rank. And this is something in their school. And this is important for the preferential admission percent plan channel. So here we find something interesting. What these stats are telling us are that students kind of know their GPA. So the GPA is measured on a scale between 1 and 7, and their bias is less than 0.1 of a GPA point. So they have fairly accurate beliefs about their own GPA. However, they have a small bias about the location of the top 15% cutoff. So this is telling us they think that the cutoff is about half a point of a GPA, a little bit less, below what it actually is. So this is not surprising because students are always given report cards with their own GPA, but they're never given any relative rank or any information about their classroom, the school at all. So what is, I think, the staggering fact is that grade compression in these schools is so large that this small bias in absolute terms turns out to be a large bias in relative terms. 43% of students think that they are in the top 15% of their school. So this is telling us a large overconfidence about your regular entry, regular admission channel, and overconfidence about your rank. Quickly, who are those who are overconfident? It looks like everyone is overconfident. So optimistic beliefs are widespread. Here, just visually, the blue line is the belief and the dashed line is the truth. The fact that the blue line is above the dashed line in all of this is a symptom of optimism. And everyone is optimistic regardless of their baseline rank in the school or the baseline ability. And there, as we said, there's optimism both about school rank and about entrance exam scores. So I would love to show you the tables here, but in the interest of time, I'll just give you a high-level summary of how we validate this belief data. Well, first, beliefs, it's true they're biased, but they correlate with the true outcomes that they represent. And beliefs and belief biases correlate with real outcomes up to 16 months after we elicited the beliefs. So for example, your belief about your entrance exam score independently predict whether you sit the exam. So conditional on controlling for your baseline ability and characteristics. But your belief about your entrance exam score and your bias about your exam score also correlates with whether independently actually predicts whether you enroll in university and whether you stay enrolled in the second year. So this is a signal that there are likely correlations between your beliefs, for example, your optimism about your entrance exam score and your preference for college. This is a symptom that this is a feature of our data. But definitely this validation exercise gives us confidence that beliefs are important in choice, but also that our survey recovers credible measures of these beliefs. So let me start with the first set of results. These are the experimental results. I'll show you impacts on admissions and enrollments. So here I show, this is Probit and Logit. The policy increased admissions by about 3.8 percentage points, and enrollment a little bit less. So there's a bit of leakage between admission and enrollment. Not everyone who's admitted enrolls. Percentage-wise, these are large effects. So what I do want to point out here is that there is something mechanical about the admission effects. So we are making more seats available, kept them reserved for these students. So mechanically, you would expect that more students are admitted. So the mechanical effect means if nothing changes, if students don't change their behavior at all, this will be the difference between 15%, which is how many people are admitted under the policy, and 11.2%, which is a baseline admission rate. So that's exactly 3.8 percentage points. So what I'm gonna point out here is that, well, with a logit, we already start seeing this is a little bit lower than the mechanical admission effect. But if you build confidence intervals around these effects, you actually cannot rule out an admission effect that is up to 70% lower than the mechanical one. So this is going to be one of the central focus of the talk. So let me show you what happened to behaviors prior to college in the next slide. So these are the impacts on achievement and on study effort. So we find a negative significant effect on achievement of about 10% of the standard deviation, and a negative effect on our study effort measure of about 9% of standard deviation. We calculated it with principal component analysis. If you look at the individual items, this is driven by fewer hours of study outside of class. Students are less likely to give their assignment on time, take fewer notes in class, but importantly, this is also driven by lower preparation for the entry exam. They lower their preparation on the entrance exam. If you look at heterogeneity of these effects, you don't see a clear pattern, but what you see is that they're negative for everyone, regardless of your baseline rank in the school, and regardless of your baseline ability measured by baseline test scores. So this is an across the board reduction in a study effort and achievement before. Now, many people have—
back to the previous question. So, I mean, you're going to focus on kind of the effect that this has on the individual students, but I kind of good point to raise again the question of what could be possibly going on in terms of what is happening on the teacher side and the school behavior side of it.
Sure. So I don't have tables here. From the teacher side, if you think of the teacher incentive, they're kind of weird. So teachers, if they want, they can decide to harm some student to benefit someone else. So it's a zero-sum game because it's a relative rank thing. So what we do, we have measures of teacher effort. We don't see that teachers change their effort. Their focus of instruction. We don't see teachers focusing on certain students or teaching certain parts of the curriculum that are harder or easier. Grading behavior didn't change. So we can do it because we have the mapping between standardized measures and grades taken at the same time. The allocation of teachers to classrooms didn't change. And another thing is support classes. You might think that for some reason they may decide schools to lower support classes. Notice we find a negative effect, and we don't see any of that. So this for us is, we take this as evidence that the reduction in study effort and achievement preschool is driven by behavior of students. Again, the fact that study effort is driven by students is kind of tautological itself, because that's the effort of the students.
So teaching incentives are complicated, right? So if I would be a teacher, I would like to bump up those students who would otherwise not go to college, right? So depending on the baseline probability or what I know, I might want to increase the performance of those who would otherwise not go.
Yes, right? And you would see evidence on that because the mapping between grades and the actual ability that we can measure would change, and we don't see that.
I think also an interesting exercise, I don't know if you already are doing that, but will be to look at those who believe are in the top 15% and compare how they respond to those who believe that are below that, because if it's really that what is driven this, you should see that the effect is driven by—
Yes, so that's an excellent point, thank you. And we do that. Let me talk about it in the next slide. Another thing that treatment didn't affect the perceived returns to college, which are large, about 200% of age 30 wages. So we take this evidence that this lower negative effect is not due to lower expected gains from college, and therefore that will lead them to say, I don't want to go, I'm gonna lower my effort. So this brings us to the channel that we are gonna be focusing on, and that is a channel of, so that I wanna point out one thing that is, it kind of stands out from even just looking at the subjective beliefs that we've measured and the effort and the effects and just thinking about it. So the subjective beliefs are compatible with this reduction in effort as a response to perceived incentives. So there's optimism. Students we've shown are optimistic about the regular admission channels, regular admission chances. So that means that they may be perceiving a regular admission as within reach, and therefore they prepare for the exam, they sit the exam when they are in the control group. But we also see that students are optimistic about their school rank. So that means that they may perceive a preferential admission when they are treated as guaranteed. I don't need to put in effort because I have a guaranteed admission. I'm in the top of my school. So that would lead them to prepare little for the entrance exam when they're treated. So this could be driving this negative effect. Now, this belief data that we've shown you alone are not sufficient to actually pin down this effect, because this effect is about the perceived returns to effort, while the beliefs that we have shown so far are at the effort that the students actually exerted. So we need a little bit more. We need to look at what are the perceived returns. To answer Andres' question, I don't have the slide here, but we looked at treatment effects by perceived distance from the cutoff. And you see that the negative effect is driven, and it's particularly negative. The effect is particularly large and negative for those who perceive that they are well above the cutoff. And the larger above the cutoff they think they are, the larger the negative effect. You do see small encouragement effects around the cutoff. However, they're insignificant. Now, maybe I should, there's a lot to be said about that, but we may talk about it in the 15 minutes after this. So that's, again, it points to, it looks like incentives are playing a role, but again, we're not happy with what we have right now. We use more data. So for a reduction in effort to be rational, students in the treated schools must perceive that effort has lower returns. So that's the idea. How much closer to an admission does one additional hour of effort get me? And it has to be that if you're in the treatment group, you think that you don't need to put in effort. So effort has lower returns. So what we did, we elicited additional beliefs about the returns to effort in the production of the entrance exam score and in the production of GPA. These were elicited through hypothetical effort scenarios. So then we develop a model that will incorporate these beliefs into a subjective admission probability. So that will tell us what is the mapping between the effort and the likelihood of an admission for treated and for control students. So that will allow us to answer the question, do the subjective beliefs actually rationalize? Are they able to rationalize the effort reduction as expected utility maximizing and do other things? So then the model, the key features of the model is first, we relax the rational expectations assumption because our belief data and the behavior of the students points to beliefs being far from rational and not accurate. The model is dynamic, and that is because that way we can capture how beliefs in high school can affect later choices and later outcomes. And then a feature of our data is there's heterogeneity across the students. There's an observed heterogeneity in ability, preferences, and beliefs. And these things are likely correlated with each other. So we're gonna allow for that in the model. Rather than showing you equations, I will show you how the model works by means of this figure. So we model both students in PASSE schools and students in non-PASSE schools. As you can see, the model is dynamic. So there's an effort choice, entrance exam choice, then admissions occur, and then there's an enrollment choice. Before the model starts, however, at time 0, students are going to form these beliefs. Now, beliefs in this graph are in red. So this is a subjective probability of an admission. And in particular, students in PASE schools are going to form subjective probabilities of being in the top 15% of their school, which will lead for them to a preferential admission. This is a function of effort, obviously. And then all students in PASE and non-PASE are going to form beliefs about the probability of a regular admission, which down the line is going to matter for their admissions. So when they make their effort decision, they're maximizing the present discounted value of their utility. And what I want to point out is that the expected value function is actually computed with subjective probabilities. So the fact that this is red means these are subjective probabilities. So they make their effort choice, then they decide on whether to seek the entrance exam, and notice how there's still a lot of red here. And that is because when they make the entrance exam decision, just like in the real world, they don't know if they have a preferential seat. They don't know what their entrance exam score is going to be. So this is still very much based on their beliefs. But after they sit the entrance exam, admissions occur through objective admission chances. So see how all the red is now gone, because it's objective admissions that determine who gets the admission or not. And then we have the last stage is an enrollment decision. And we decided to model it because we do see some leakage in the data. So we thought it's important to also model that. So the key feature of the model are going to be these subjective beliefs. So there's subjective.
I mean, Michela, if I can sort of very briefly interrupt, I mean, the beliefs are also complicated by the fact that people may take into account that other people are making exactly the same maximization problem. So if you think that other people are exerting less effort, you think it might be optimal to exert even less effort because the average quality is going down.
Yes.
And also on that point, the teachers could be instrumental in shaping these beliefs. So if the teacher tells me you're in the top 15%, you're not in the top 15%, that could shape the beliefs as well.
Yes. Wow, there's a lot of points. These are all very relevant. And I wish I could talk extensively about it. But so Barbara's point was about beliefs about others. Yes. What we're going to do here, we're going to take them as best responding to whatever they tell me they think the top 15% cutoff is in their school. And in fact, you do see that in treated schools, they do believe that the top 15% cutoff is below than in control schools. And we're assuming you're best responding to that. We will have a counterfactuals where we simulate rational expectations, and there they are playing a game. And we're going to find what the counterfactual belief is. Now, regarding the question about teacher shaping beliefs, so the question that is, that's an important question. The point is there any belief revision? And I think that's also related to Barbara's point. And again, I will have to skip over it because this is a 45-minute talk, so I cannot talk about it, but we have looked at that. And so there was no transmission of relative rank information officially. Officially, there was no transmission of relative rank information. However, we do find that for students who are in the top 20% of their school, you see that their belief bias about the cutoff is a bit lower by 20%. So that means it looks like endogenously, those who have most to gain about knowing where the cutoff is, either by themselves or because the teachers helped shape their beliefs informally, we do see that that occurred. So we have an extension of the model where we delve into that. And I can already tell you that, well, in the data, we see that this reduction is very small. It's just 20% just for the top. And so in the model extension, we show how suddenly this improvement in the belief is not enough to avoid the negative effects on admissions and enrollment. So we simulate what would those effects have been had students not revised their beliefs, and we don't see that they matter. They matter a bit for effort, but not enough to move the outcome of policy relevance. So again, I could spend half an hour just talking about that. I hope that answered the question. So I'll have to then go a little bit fast over this, but for identification, we're to separately identify beliefs from preferences, we obviously leverage a lot on the fact that we elicited these beliefs, but we also exploit the randomization. So in fact, in estimation, we're going to assume that the unobservables are balanced between treatment and control, thanks to the randomization, and that's something we exploit also in identification. Generalized indirect inference, that's a way of smoothing the objective function that allows you to use faster gradient-based methods in optimization. So let me show you the results in the last 5 minutes I have. In terms of model fit, so we're still working on this, but the model is already cast to college that I've shown you, the overconfidence that I've shown you, the correlations in behaviors over time, which is a symptom of permanent heterogeneity, both in observed and unobserved features, correlations between beliefs and behavior we capture, the treatment effects we capture. So these are all the key features that you really want to capture, we get them. So this is one of the main results from the model and the data and everything that we put together. So this is telling us, okay, what are the impacts of the policy on the perceived incentives? Notice how this comes from the belief data we've measured. So you may think that there may be something else going on in the school on top of the perceived incentives, but this is not something that we imposed on the data by means of our model. So what the data is telling us is that students perceive that 1 additional hour of effort has lower returns in terms of a likelihood of an admission, lower by about 5 percentage points on average. And this is there for everyone in the school, regardless of your baseline rank in the school, if you're at the bottom or at the top, they all think that the policy made it easier for them to go to university. Now, a natural question is, what is the truth? So if they had correct beliefs, how did the policy in reality change the incentives? Now, this is what the effects would look like under rational expectations. Only for those at the very top of their school, the policy did, in fact, lower their incentive to exert effort. There's a bunch of people around here for whom the policy didn't do much, and these are the students I told you at the beginning, those who are already going to university and graduating in the bottom 85% of the school. And then there's this lower ranked students in the school. They are those for whom effectively the policy is putting university within reach that previously was not within reach, but they think the opposite. They thought it was within reach, and now they think it's guaranteed. For those who are interested in technicalities, we need to solve for a fixed point problem here to find the rational expectations equilibrium. So then the second question, by the way, the average effect on achievement if students had rational expectations would be of the same magnitude, but opposite sign. It would be positive.
Michela, I think we're kind of almost out of time, really. So maybe kind of, 30 seconds to wrap up the key points.
So I am at 43.50 minutes, but according to my clock, I still have 2 minutes.
Okay, go ahead.
I think in 2 minutes, I can conclude by saying, look, if you assume that there was no effort response to understand what's the role of the effort response, well, you find that the enrollment effects, they would have been larger. So the enrollment effects are reduced by 25%, by a quarter. So the response of pre-college effort can adversely affect later outcomes by affecting college attendance. Who are the students who experience negative admission effects? It turns out, let's just focus on this in the interest of time, they are those with the highest baseline test scores. They are more disadvantaged. Within the group of disadvantaged students, they are among the most disadvantaged, and they tend to be those who have a higher preference for college and more optimistic beliefs. So these students who experience negative admission effects are those who potentially would even stay longer in school because they have a higher preference. So what's happening here? These are students who would have made it to university. The policy comes in, they think university incorrectly is now guaranteed. They stop studying. They don't have the preferential admission, but now they also miss the regular admission. We look at longer term outcomes and belief revision. We don't have time to talk about it. So let me conclude. Preferential admissions are implemented worldwide to raise college enrollment of disadvantaged students. And we show that when students are misinformed, they can have perverse incentives that lower the enrollment chances of the most high achieving and the most underprivileged. Because preferential admissions target students who don't have information about the admission process, this could be a widespread phenomenon that so far has gone undetected. Clear implication from policy, let's look at what information would do here. And for research, incorporate beliefs in models used for predictions. Again, if you impose rational expectations on the data, you're gonna miss this effect. You will fail to detect it.
Thank you very much, Michela.